obvious question to start with. How is the problem I've situated you with here? How is this problem different from the problems that you've encountered so far? Hmm? We've got a value, we've got an area. It's the mean. Yeah, we haven't been asked. We haven't been given an unknown inside the normal distribution setup. So in this mini lesson, we're going to look at how the heck do we get to that to those values, and the answer is we get to it by considering the standard normal. So these are the steps. So again, I will produce videos which are just more direct solutions. This is the theory behind it. So step one, we are going to use the standard normal distribution. So we're going to use Z is distributed normally between 0 and 1 to find the relative position. So in other words, we're given at x less than 3, the probability is 0.6915. So what would be the Z value at 0.6915? That would be its relative position to the mean, right? That's its relative position. So if it works out that Z is 1.2, then we would know it's 1.2 standard deviations away from the mean. So that's what that step does. Use Z to find the relative position. And then number two, we're going to use, sorry, I forgot that I was not zooming up there. Number two is we're going to use, you know that formula we had before, the Z equals X minus mu over sigma? So we're going to use that formula to work out, in this instance, mu. Just a reminder that that's mu. It's not the letter U. It has a little tail like I've given it there. Make sure you use that tail. So zooming out, this is how I've tried to capture that here. Okay, so the normal distribution that we're given is that we've got a normal distribution with a mean mu that we don't know the value of. That's so I've just listed it as mu. Because it's 0.6915, I can say with confidence that 3 is going to be to the right of mu. Yeah? Because this first bit is 50%. So if it's 69.15%, it's going to be above that. I don't know whether 3 is there or there or there. It could be any of those sorts of things. I don't really know, but I would say that it's roughly there. And I'm transforming this particular normal distribution into a standard normal distribution with the same area under the curve of 0.6915, but instead I need to work out that value of Z. That looks like a 2 there, I'm sorry, but it's meant to be a Z. I'll try and make it a bit more angular. Okay, so that's the critical thinking. The rest is process, which of course I will go through. But just, is there any questions about the approach, why we're doing it, the how I'm about to do? Anything at all? Gabe, you okay? I love clarification questions. I don't care what they are. They all really help everyone out when they get asked. Alex? Okay, so here's the process. First of all, just like you've been doing in 16C, we're going to work out the probability of Z less than Z, so big Z less than little z, at 0.6915. Okay, so we work out that probability using our inverse norm on our calculator. So I'm going to switch Aruni to the calculator view, and I'm going to go menu, 5 for probability. It's so much faster to use the keyboard than the clunky arrows. 5 for distributions, and 3 for inverse normal. I'm going to put in that area, which is 0.6915. And by the way, because I've been watching people use their calculators, once you've got that in, if you don't need to change these, just go straight into pressing the enter key, and then again, and then it's out. So you can see that I've got 0.500106626. I won't write all of that down. So that gives me a Z value of 0.5001. That'll do. I'll switch over to the screen so you can see what I've written down there. Now, this is how I write it out, but I just saw Jane in passing, and I said, oh, I notice in past tests, the solutions always have inverse norm 0.695 0, 1 written down in the solutions. Is that what we're supposed to do? And she said, well, you don't get marks for it per se, although internally we might give you a mark if you write that down and then you get your final answer wrong. But in the end of year exam, they won't give you a mark for that per se. But she says we encourage students to write it down so that when we're marking your work internally and we can see that you've used norm PDF instead of norm CDF or something like that, where we can give you much better feedback because we can see what calculator operation you tried. So you'll see in my videos, I tend not to write that down because it's not my normal thing to do, but probably get into the habit of writing it down so that we can give you feedback if you do stuff up the actual calculator step. So that's just a bit of an aside. She did say, which is what I have said to you as well, that you should always draw a diagram down. You will get marks for diagrams if you write them down, if you get other things wrong. Okay, so you can see my diagrams down there on slide 2. So that's a sidebar. Okay, so we've now got our Z value. So what we can do with that Z value is pretty neat. We can now put that, so just to remind you, I wouldn't normally write this down. So to remind you, the Z value is calculated manually by going Z equals X minus mu all over sigma. But we've just worked out the Z value, so we can substitute in 0.5001 for Z. We can substitute in the score that we were aiming for, which was 3. We can substitute in sigma because we're given it, which means that we'll have an equation with just one unknown, and that's mu. That is great news because that's what we're trying to find out. So I do my substitution. So again, I wouldn't normally write this in. I'm doing it just for this theory here. So I write in my value for Z. I write in my value for X that I've got. I write in my value for mu, which is unknown, so we just got to write mu. And I write in my value for sigma, which is bzzzt, bzzzt. It's not 4 and it's not 1. It's not 6. It's 2. Hamish, since you said it, explain it. Excellent. Excellent. This is always written as mean, comma, variance, sigma squared. Okay, so if it's sigma squared, then the standard deviation is going to be 2. 2 squared equals 4. So that was a trap. I literally deliberately did that to trip you up. So don't feel bad if you thought, oh my God, why didn't I say it? I deliberately tried to trip you up with that one. Okay, so if I go to my calculator and if I go, there's 0.5001, but with more decimal places, I'm going to multiply both sides by 2 to get rid of the denominator. Great. Multiply it by 2. I'm going to get 1.00000213. So I've got 1.0002 is equal to 3 minus mu. And then I can finally conclude that mu must therefore equal. And now I'm getting a bit silly with all my decimal places. So I think I'll just say that mu, for all intents and purposes, must be 2. Oh, sorry. Thanks, Charlie. See what I did there? So multiply both sides by 2, but I can see I'm basically aiming for 1 here. So when I add mu to that side and subtract 1 from that side, I get mu is equal to 2. 3 minus 2 equals 1. Okay? Questions? So, yes. This one? Okay. So any normal distribution can be transformed into a standard normal. Standard normal has a mean of 0 and a standard deviation of 1. So 1, 2, 3 units, etc. So by considering the same area under the curve, so 0.6915 under this one and 0.6915 under this one, I will find relatively, I will find the Z value, which is relatively the distance away from 0, however many standard deviations away from 0. That's what that diagram means. It's a transformation of this one here. So what you're literally doing is you're drawing the diagram out again and putting the same area underneath the curve. Then you're using inverse norm with that area, 0.6915, to work out what that little Z value is there. Then you're basically working backwards, given that value, and given the score, what would the mean have to be in order for this equation to work? And that's the rest of it there. Okay, so step one, you're using this step here, PZ of less than Z equals the area, to work out the Z value. Step two, you're using the formula to work out the unknown value. Okay, this is what I'm going to do. I'm going to pause the video and I'm going to give you a chance to try this particular problem. How is it different? Instead of the unknown mean, it's an unknown variance or standard deviation. I've made a bit of a start on the problem up here with the diagram. So I'm told that the mean is 0.5, boom. I'm told that for x less than 0.25, so I know it must be down here because it's less than 0.5. I know that now because that's a given, is equal to 0.1587. So I'm just having a bit of an estimate as to what about 16% of that area would be. It's probably a bit further down, doesn't really matter, but that's my diagram done. So what I'm going to do now is I'm going to work out step one, which is what is the corresponding Z value. So I take the probability of the standard normal, Z less than little z there, equals 0.1587. So same area, but now I'm looking for the corresponding Z value. That gives me a Z value of, again, into the calculator, inverse norm. I'm going to reuse this one. I'm just going to put 1587 in. 1587. And I get negative 0.9998. So 0.99982. There we go. Now, that's step one completed. I've got my Z value. Now I'm going to use my formula. So negative 0.99982 is equal to, well, what was the X value that I was given? 0.25. What was the mean that I was given? 0.5. What was the sigma that I was given? I wasn't. So I can put sigma down there. Okay, and now it's just a matter of solving it, right? So I'm going to multiply both sides by sigma, and I'm going to get negative 0.9982 sigma is equal to 0.25 minus 0.5, so negative 0.25. And then I'm going to divide both sides by negative 0.9982, and I can see that's basically minus 1. But I can do it, though. 0.25 divided by that. I should have made that negative 0.25, so I'll just go back and fix it. Divided by that is equal to 0.2500426. So basically, it's equal to 0.25. So that's sigma. No, that is sigma. If I was asked for the standard deviation, if I was asked for the variance, if instead of saying find sigma, it said find the variance, then my last line would be, therefore, sigma squared is equal to 0.25 squared, which is 1/16th, whatever that, I can't even think off the top of my head. So 0.25 squared, which would be 0.0625, which is the variance. Okay, so the variance is the standard deviation squared. So be very careful to answer what it asks for. If it says find the variance, then you just find sigma and then square it to get the variance. If it says find sigma, then just find sigma and your job is done. Tian, what does inverse norm do? Okay, so inverse norm says if you know the area, please tell me the value. So remember, area equals probability. So if you're given the probability, work out what that value is. Note that it's z less than z though, or it's the less than value. So I know this is no good for the video, but I'll just show you on the board here. If you are given x greater than 0.25, then to use the inverse normal function, you're going to have to convert it into an x less than 0.25 problem. I promise this will go in a separate video as an example. So if you do that, if you're given x greater than a value, then you need to convert it into x less than the same value, and then put that into the inverse normal function. So the inverse normal function is always looking at the left-hand area, never looking at the right-hand area. So the inverse normal function is always looking to the left, never looking to the right. So given the area on the left, which you can work out, or maybe you're given it, like we are in this problem, it will return what that little value there is. Yep.